Welcome back. In the next part of this lecture, we're going to be talking about applying more than one transformation to a basic shape. When we do, we have to keep in mind the order in which these transformations need to be carried out. So when I do them, I prefer to do my horizontal transformations first and then my vertical transformations afterwards. You could switch that order up if you wanted, doing vertical things first and then horizontal things after. The one thing that you can't change is the order in which we do stretches and shifts. You'll notice here on my list in the way that I've got things laid out, stretches and flips need to come before shifts. So if I had horizontal stretches and horizontal shifts, I would have to do the stretch first before I do the shift. And same thing for vertical transformations, I would have to do any vertical stretches or flips first before I do any vertical shifts. Of course, the stretching and flipping, those are done at the same time. So even though they really are two separate transformations, I'm not going to split it into two steps. I'll do those both all at once. So if I had a vertical stretch and also a flip, or also a horizontal stretch with a flip, I would do both of those transformations simultaneously. So when I look at a function, I'm going to have to think about what are the transformations and also what are the order in which I'm going to carry them out. So for something like this function, negative 2x minus 1 squared plus 1, I first have to recognize that the basic shape is an x squared function, so I would need to graph that. And for my transformations, I have a shift to the right by 1, I have a vertical stretch and flip, I have a shift upwards by 1. So for my transformations, I would have to first, after I draw my basic shape, take my basic shape and go 1 to the right. Once I've done that, take that and transform it by stretching it and flipping it. And once I've done that, go one step further and shift everybody upwards by 1. So that means to graph f of x, I would actually have to do 4 separate little graphs to get me there. I'd have to start off with my basic shape, then do my horizontal shift, then my vertical stretch and flip, then my vertical shift. And as always, every single graph that I do is going to be a well-labeled one, so I'm going to need to make sure that all of my graphs have their equations labeled as well as all their important points. So let's get ourselves started. For this first graph, I can see that this is a square rooting function, and I can see two transformations. The 1/2 is attached to the x inside my square root. I know that that is a horizontal stretch. I'm going to be dividing each x by 1/2. And that this minus 2, that's not part of my square root, it's outside of it. That's a minus 2 at the very end of my function. That means I'm going to be going down by 2 or subtracting 2 from each y value. So I'm going to then do 3 little graphs. I'm going to start with my basic shape, the square root graph. Then I'm going to divide each x value by 1/2, or in other words, multiply every x by 2. And then once I've done that, I'll subtract 2 from all my y values. So we'll start with our basic shape. Our square rooting graph goes through 0, 0, 1, 1, and 4, 2. And of course, we need to label its equation. And there we go. We've got our basic shape nicely drawn. And now my transformations, the first one I'll do is my horizontal transformation. And I'm going to do that by dividing every x value by 1/2, which is the same as multiplying every x value by 2. So instead of 0, 0, I will have 0, 0, because when I divide that x value by 1/2, it stays as 0. But for 1, 1, when I divide that x value by 1/2 or multiply that x value by 2, I get the point 2, 1. And 4, 2, when I do the same thing there, divide the x value by 1/2 or multiply by 2, that gets me the point 8, 2. And there we go. We've got ourselves our stretched graph, y equals square root of 1/2 x. Okay, so first transformation has been accomplished, and now to finish things off, I need to do my vertical transformation, shifting things downwards by 2. So I'm going to then take the graph that I just made and subtract 2 from all the y values. So 0, 0, I'm going to subtract 2 from its x coordinate, or from its y coordinate rather, to get me 0, negative 2. I had 2, 1. When I subtract 2 from its x coordinate, I'll have 2, negative 1. And I had 8, 2. And when I subtract 2 from its y coordinate, I have 8, 0. And I'm just going to label that with its points. And the only one that I really have to label here is 2, negative 1. The other 2 points are on the x-axis and on the y-axis at a tick mark, so I can leave them unlabeled. And there we go, that's my graph of y equals square root of 1/2 x minus 2. I've said this before, but it's worth mentioning again. The reason why we label everything is, number one, so that somebody who's looking at this knows what the graph was supposed to look like. If you're looking at the way that I've drawn it, you might even say that my drawing is not very good. It almost makes it look like this is a wobbly straight line. And that's, again, my poor drawing skills. But now that I've labeled this with its equation, whoever's looking at it knows that this should have that sort of curvature that the square root function has. It's just me as a human, I'm not able to make that happen with my drawings, unfortunately. But the labeling is taking care of that for me so that whoever knows what I've drawn knows what I intended to draw. All right, so we've done one example. So we've only had one of each kind of transformation, one vertical, one horizontal. Let's do one where I've got more than a couple of transformations. Here, 3 transformations. I have the absolute function, the absolute value of x is my basic shape. And inside the absolute value x function, I have a minus 2, which means we're going to be going to the right by 2. Or in other words, we're going to be adding 2 to every x. And then for the vertical transformations, we have vertical stretch and flip. And I'm going to be doing that by taking our y values and multiplying them all by negative 3. And then we have a vertical a vertical shift of upwards by 1. I'll be taking all of my y values and adding 1 to them. The way that I'm going to do my transformations, I'm going to start off doing my horizontal transformation first, and then when it comes to my vertical transformations, I'll need to remember that the stretch and flip happens first before I do my shift upwards by 1. So that means that for my graphs, the very last one that I'm going to do will involve the shifting upwards by 1. I'm going to start with my basic shape, though. So let's start with absolute value of x, which passes through 0, 0, 1, 1, and negative 1, 1. There we go. And let's just label that with its equation and the coordinates of its points. There we go. Basic shape accomplished. The next transformation to do, I'm going to do my horizontal transformation to the right by 2, adding 2 to all of my x values. So instead of 1, 1, I will have 3, 1. Instead of 0, 0, I'll have 2, 0. And instead of negative 1, 1, I'll have 1, 1. And now let's draw ourselves our lines, and then label things as always. One thing just as on a practical level, you'll notice I'm labeling things at the very end after I've drawn my shapes. And that's just for practicality. I don't know exactly where my graph is going to run into, and I don't want to have to erase my labels and then redo them again afterwards. So once I've plotted my points, I'll have to remember afterwards to come back and label them after I've actually drawn the function itself. Okay, so we've done our horizontal transformations. The last two transformations that we have are the vertical ones, and again, we're going to do the stretching and flipping first before we do our shifting. So that means what I'll need to do is start by multiplying all of my y values by -3. So my original y value, I had the 0.31, but I'm going to multiply its y value by -3 to give me 3, -3. 2, 0, its y value is 0. Multiply that by anything, it stays as 0. The last point I had was 1, 1. Multiply its y value by -3, and I've got 1, -3. And now we'll draw our function. And then we'll do our labeling. And as always, labeling our points. And then labeling our equation. So this is absolute x minus 2 all times by -3. Okay, so we're almost finished. One last transformation to do, and that was the shifting things upwards by 1. So shifting things upwards by 1, the little +1 that we'll have at the end, means that I'm going to add 1 to all of my y values. So instead of 3, -3, I'll have 3, -2. 2, 0 shifts upwards to 2, 1. 1, -3 shifts upwards to 1, -2. And then I have my completed graph. Of course, as always, make sure that we label everything, and it's always a good plan to, once you've finished graphing things, just to stand back and ask yourself the questions like, did I label my x-axis and my y-axis? Did I label my tick marks? Did I label my points? Did I label the equation itself? It's very easy because there's so much that needs that level of detail and care, all that labeling, to have missed something along the way. Here, because I've got my axes already drawn for me, I didn't have to worry about maybe forgetting to label one of them with an X or a Y, or labeling my tick marks. If you're drawing by hand and creating your own axes, you'll have to remember to label all of those. But even still, just labeling points and equations alone, there's lots of stuff to remember. So I look back at my graph and I check to see that all my points that I needed to label have been labeled. The equation has been labeled, and that's true for all of the graphs that I've done. I've labeled with equations as well as their coordinates of their points. Okay, let's do one last transformation. We haven't done a cube root graph yet, so it's kind of nice to get a chance to do that. Cube root graph, we remember that this has the basic shape that's kind of like the x cubed graph, except instead of sort of scooping upwards, it heads off to the right and off to the left. It passes through the same basic points, 1, 1, 0, 0, and -1, -1. So easy enough to remember that. It's just got a slightly different shape compared to the x cubed graph. Okay, for my transformations, I can see again 3 transformations that are going to happen. I have a +1, which means we're shifting things to the left. We have a vertical stretch by a factor of 3. We're shifting things upwards by 2. So I know again that I'm going to do my horizontal transformation first, shifting everyone to the left by 1, or subtracting 1 from all of my x values. So 1, 1 shifts over to 0, 1, 0, 0 shifts to -1, 0, and then -1, -1 shifts over to -2, -1. And that would be cube root of x plus 1. For the 2 vertical transformations, I'm going to do, again, as always, the stretching and flipping before I do my shifting. So for my next transformation, I'm going to multiply all of my y values by 3. So instead of 0, 1, I would have 0, 3. Negative 1, 0, the y value is 0, so when I multiply the y value by anything, it stays as a 0. And negative 2, negative 1, when I multiply its y value by 3, I get negative 2, negative 3. So we have our cube root graph. Now it's been stretched vertically. It's 3 times taller than originally. And again, making sure that we label everything, the points, as well as the equation. So I'll label that 3 cube root of x plus 1. All right, so for my last transformation that I have to do, I've got the shifting things upwards by 2. So that means I'm going to be adding 2 to all of my y values. So now let's get into that. Adding 2 to all of my y values, you can see on my y-axis I don't have a tick mark for 5, and that is where my y value is going to transform to. So I'm going to have to come back and label that point afterwards. So 0, 3 moves upwards to 0, 5. I had negative 1, 0. That's going to move upwards by 2 units to negative 1, 2. And the last point that I had, which was at negative 2, negative 3, I'm going to move that upwards by 2 units to negative 2, negative 1. And so let's label all of that. Negative 2, negative 1, negative 1, 2, and I'll label that point 0, 5. And then the last thing for me to do, of course, is to label my equation. So let's do that over here. 3 cube root of x plus 1 with a little plus 2 at the end. And there we go. We've got our nicely transformed graph, our cube root graph that's been shifted to the left, then stretched vertically by a factor of 3, and then shifted upwards by 2.